An active volcano could be sleeping directly beneath your feet, and you would have no hint it was there. Beneath the glassy surface of a lake, or under the reinforced concrete of a city, the planet's most formidable anomalies remain unseen. The Earth feels solid only because we almost never look below its skin. Our shared image of a volcano, a neat, conical mountain, is not just naive, it's dangerously incomplete. So if the greatest threats aren't mountains, then what exactly are they? They are absences, voids in our perception. The greatest volcanic threats are often the ones you never notice, because they aren't mountains at all. Some are immense depressions in the crust, masquerading as placid lakes or ordinary valleys on a map. Others lie buried under kilometers of seawater, pinned beneath the crushing pressure of the deep ocean, where no casual satellite image will ever betray their outline. The classic image of a volcano, the cone-shaped peak with smoke, feels reassuring. It's simple, it's distant, and that it is dangerously incomplete. That postcard silhouette is a comforting fiction we repeat to ourselves to keep the world small and predictable. Consider the evidence we do have. Until 2013, the largest single volcanic structure known on this planet was effectively invisible to us. It is called the Tamu Massif, an anomaly sprawled across the abyssal plain of the Northwest Pacific. Its footprint is not measured in acres, but in territories, rivaling the landmass of a small country. For millennia, it was a ghost, present in the seafloor, but missing from our mental map of Earth. Subsequent analysis has only deepened the enigma. A 2019 re-examination of its structure suggested it may not be a single volcanic edifice at all, but a sprawling, interconnected complex of features stitched together in the dark. The further our instruments and deep ocean submersibles peer into the abyss, the more colossal and incomprehensible these hidden worlds become. The ongoing debate among geologists is not a failure of science. It's a reaction to sheer scale, to something that refuses to fit into our classifications. What we once thought was one giant may, in fact, be a family of them, spread across the seafloor like an archipelago of fire. This is the reality. The volcanoes we recognize on land are often just the exposed tips of vast magmatic systems. They are superficial evidence of a larger truth, the symptom of structures that extend beyond the horizon we can see. The existence of a structure like Tamu Massif, whether a singular leviathan or an entire abyssal mountain range, forces a more fundamental question. It is not a geographic fluke, it is a symptom of a planetary process operating on a scale that dwarfs human history and human imagination alike. So how does a planet build such a monster in secret, shielded by water, distance, and time? And what engine, deep within the Earth, drives the creation of these hidden worlds, and keeps them, for now, just out of reach? The engine that assembles these hidden worlds isn't a machine of metal and gears. It's the planet itself, alive, in its own slow, indifferent way. A dynamic system running on two fundamental, relentless processes. Think of them as geological conveyor belts, forever reshaping the surface, dragging new material up from far below. First, let go of the idea of a solid, unbroken shell. The terrestrial crust is fractured into immense tectonic plates, adrift on a sea of semi-molten rock. Where these plates pull apart, along the mid-ocean ridges our submersibles map. Magma from the mantle wells up to fill the void, creating new seafloor and vast chains of submerged volcanoes. But where these plates collide, one is inevitably driven beneath the other in a violent process called subduction. The immense friction and heat of this descent melt rock, feeding the explosive volcanic arcs that form the infamous Ring of Fire. The second mechanism is more insidious and far more direct. Picture a stationary blowtorch fixed deep within the Earth's mantle, a thermal plume of superheated rock punching upward. Now drag the tectonic plate, our conveyor belt, slowly across its flame. That is a hotspot. For tens of millions of years, the exact figure shifts as the dating improves. The Pacific plate has been grinding northwest over such a hotspot. Each point where the plume burns through the crust becomes a new volcano. This is the origin of the Hawaiian Emperor Seamount chain, a direct, linear scar across the seafloor, an anomaly proving the planet's motion over a fixed point of internal fire. So, volcanoes we observe aren't random geological features. They are the surface expressions of a planet in constant grinding motion. They are, in the most literal sense, the marks left by the planet's internal conveyor belts. These mechanisms are engines of raw creation, hauling fire and new land up from the abyssal depths. But honestly, power is paradoxical. When one of these systems erupts with sufficient force, the atmospheric consequence is not a wave of heat. You don't get a warmer world. You get the opposite. A descent into planetary winter. A chilling, sun-blocking darkness that can rewrite the course of life on the surface. And we have the records to prove it has happened before. Though how many times it has happened without leaving a clear trace remains, for now, unexplained. The most visceral of these records was written in fire and ash in 1815, at a place then unknown to most of the world, Mount Tambora, in what is now Indonesia. The eruption was the largest in recorded human history, an event of incomprehensible violence, the planet tearing open its crust. But its most profound consequence was not the immediate blast, not the shockwave or the roar. It was the silence that followed. The next year, 1816, an affliction settled over the northern hemisphere. A persistent, dry fog that dimmed the sun and bathed the landscape in a strange, reddish hue. It was not a cloud front you could watch roll past, but an atmospheric veil that refused to move, a kind of unexplained film wrapped around the world. In New England, heavy snow fell in June. In Europe, relentless summer rains swelled rivers, drowned fields, rotted crops where they stood, and let mass starvation take hold. It became known as the year without a summer. The cause was a paradox, a planet plunged into a chilling, multi-year twilight by a distant pillar of fire. This climatic anomaly is documented as a volcanic winter. The mechanism is not the ash that falls back to Earth, but the colossal quantity of sulfur dioxide gas injected into the stratosphere. There, in that high layer, it converts into sulfate aerosols, fine particles that spread into a reflective layer, scattering sunlight back into space before it can warm the surface. The planet's thermostat is turned down, globally. We don't have to lean only on 19th century testimony. We have a modern, precisely measured analog. In 1991, the eruption of Mount Pinatubo in the Philippines, a significantly smaller event than Tambora, was powerful enough to inject 20 million tons of sulfur dioxide into the stratosphere. The verifiable result was a measurable drop in average global temperatures for the next 2 years, a planetary fever, broken by a geological shiver. And these are only the events we have recorded. The geological record hints at eruptions in deep time, like the Siberian and Deccan traps, that were orders of magnitude larger. Events linked not just to bad harvests, but to planetary mass extinctions. We have witnessed the effect. We have documented the atmospheric consequences. We understand the mechanism. But that knowledge only sharpens a more critical and far more unsettling question. Can we see it coming? Consequences. And this knowledge leads to a single question. Can we see it coming? The answer is a paradox. Technically, yes. Existentially, no. A volcano is not a simple machine. No switch, no predictable result. It is a chaotic system of immense pressure and heat. governed by physics we only partially comprehend. We are not deaf to its workings. Our instruments listen constantly, like a submersible in the dark. We monitor the subtle tremors in the Earth's crust, the almost imperceptible swelling of the ground as magma rises, and the changing chemistry of the gases seeping from its vents. We collect the data. We build the models. We hope the patterns mean what we think. But here lies the terror. The same signals do not guarantee the same outcomes. Imagine two seismic signatures, archived weeks apart, on different sides of the planet. Both show a similar pattern, a low-frequency harmonic tremor, indicating magma movement deep below. Both are accompanied by a slight increase in sulfur dioxide emissions. As a geologist, you must make a recommendation. One of these signatures preceded a gentle, effusive lava flow on Mount Etna. It was a spectacle, glowing rivers of rock, an eruption treated almost like a festival. The other was a prelude to a catastrophic explosion, the kind that entombs cities in ash. The data looked the same. The results were civilizationally different. That is not an error, it's the system. This is the impossible challenge faced by those who stand watch. They are tasked with listening to the planet's breathing and learning to tell the difference between a harmless sigh and the sharp intake of breath before a roar. Yet this entire exercise, this attempt to decipher the planet's intentions, is predicated on one flawed assumption: that we're looking at a mountain. That assumption forces a final, more chilling inquiry. What happens when the greatest volcanic threats on this planet aren't mountains at all? The answer to that question pulls us straight into what is honestly the most unsettling category in all of geology: the supervolcano. These systems do not build mountains. They are so immense that after an eruption of sufficient magnitude, the ground above the emptied magma chamber simply gives way. It collapses, leaving behind a vast depression known as a caldera. These features are often hidden in plain sight, masquerading as calm lakes or sprawling national parks. You may have walked through one, entirely unaware of what you were standing inside, oblivious to the true nature of the ground beneath your feet. So pause for a moment. Let that sink in. The idyllic park you visited, the tranquil lake you framed on your phone, wasn't located near a volcano. That entire landscape was the volcano. Its scale is so overwhelming that, from ground level, it effectively disappears. Consider the evidence. Yellowstone National Park in the United States, Lake Toba in Indonesia, Lake Taupo in New Zealand. These are not just scenic destinations. They are scars. They are the visible remnants of some of the most violent events in this planet's recent geological history. This is where our sense of time betrays us. We live our lives on the scale of decades. The planet moves on the scale of millennia. A volcanic system that is active on a 100,000-year cycle looks extinct to a creature that rarely sees a century. It creates a very convincing illusion of permanence. The Toba caldera is the clearest example. For years, the prevailing theory argued that its eruption, roughly 74,000 years ago, nearly erased us, cutting our ancestors down to a few thousand surviving individuals. More recent analysis suggests humanity was more resilient than that our lineage bent but did not break. In a narrow sense, that's comforting, but it does nothing to reduce the power of the event itself. It proves that an eruption of that scale is possible, one capable of fundamentally reshaping the global climate. And it proves that we have been living on top of these sleeping giants the entire time. We have now stared into the caldera, into the planet's ultimate expression of destructive power. We have contemplated a force that casually dwarfs all human ambition and comprehension. But what if this story of annihilation is incomplete? What if the very same geological engines that threaten our existence are also the foundation on which it was built? The question before us is not speculation. It is a statement of fact. The narrative of annihilation we have constructed is incomplete because it has largely ignored the genesis. After witnessing the planet's capacity for destruction, we now have to face a final, unsettling truth. Without volcanoes, we would not exist. The atmosphere we depend on is a volcanic legacy. In Earth's primordial past, relentless outgassing from countless fissures built our first skies, releasing the water vapor that would cool, condense, and fall to fill the oceans. The ground beneath our feet rests on the hardened remains of those same internal fires. Every island, every continent, owes its existence to this continual, violent act of creation. A lava flow is not only an agent of destruction, it is terraforming in its rawest form. And from the ash of annihilation rises the genesis of civilization. Volcanic soil ranks among the most fertile on Earth. The groundwork for agriculture, for societies, for entire empires, was laid in the shadow of the very forces that could erase them. Here lies the final synthesis. The evidence drags us toward a single conclusion. For humanity, volcanoes are both the threat and the foundation. They are the creative and destructive heart of a world that refuses to remain static. The tremors we monitor, the calderas we map, the submerged giants our submersibles glimpse in the dark. These are not isolated anomalies. They are the respirations of a living system. To understand these forces is to recognize our precarious position inside a process that is utterly indifferent to our existence, yet directly responsible for it. We began this investigation searching for hidden mountains of fire. We end with a more profound realization. The cone, the caldera, the underwater massif. These are only symptoms. In a very real sense, the true supervolcano is the planet itself. The truths of this world rarely sit on the surface. They have to be excavated. If you choose to continue this descent into the unseen, subscribe and bear witness with us. And one final query for your own analysis. What other colossal force do you believe is operating just beyond our perception? Leave your findings in the records below.